Hello world, it's Takoya speaking. Welcome to episode 3. In this episode we will talk about the following. Define requirements of our business review app. Translate requirements into GraphQL type definitions. GraphQL first development. This paradigm is an approach for building apps that are driven by the GraphQL API design. The process begins by describing GraphQL type definitions. In our case, we would synthesize them from business requirements. These type definitions then become the basis for the API implementation, database data fetching code, and client application code. Your application data is a graph. A graph is a fundamental data structure that is composed of nodes, the entities or objects, and relationships that connect nodes. Graphs are an intuitive model that can be used to represent many different domains. We produce a data model by examining the business requirements of a domain, drawing a diagram of the objects and arrows showing how they are connected. That is a graph. Alright, let's go through this process for our business review app. Users should be able to 1. Search for a list of businesses by category, location, and /our name. 2. View details for each business, details including name, description, address, photos, etc. 3. Reviews for each business, including a summary for each business, and rank user search by favorably reviewed businesses. 4. Create a review for a business. 5. Connect friends and users who have tastes that the user likes, so as to follow friends' reviews. 6. Receive personalized recommendations based on reviews previously written, and social networks. Now that we've identified the requirements for our app, let's think about the data requirements and model that describe it. First, what are the entities? These will become nodes in our graph. We have users, businesses, reviews, and photos. Next, how are those entities connected? These connections are modeled as relationships between them. 1. Users write reviews. 2. Reviews are connected to a business. 3. Users upload photos. 4. Photos are tagged to businesses. Having translated our business requirements into the graph data model, we can now formally write our GraphQL type definitions using the GraphQL schema definition language. With the GraphQL STL, we define the types, the fields on each type, and how they are connected. Our type definitions will become the specification for the GraphQL API and guide the rest of our implementation. This process is known as GraphQL first development. Since GraphQL services can be implemented in any language, a programming language-specific syntax is not relevant for all GraphQL implementations. Therefore, the programming language agnostic GraphQL STL is used to define GraphQL types. Previously, we introduced the basic syntax of the GraphQL schema definition language using a simple movie and acted GraphQL schema. Let's create GraphQL type definitions for our business reviews app based on the requirements we created. Note that the entities we identified become GraphQL types, properties of the entities become fields, and connections or relationships connecting the types are defined as fields that reference other types. Each type contains fields, which can be scalar types, objects, or lists. Each type should have some field that uniquely identifies it. ID is a special GraphQL scalar used to represent this unique field. Internally, we treat ID fields as strings. The exclamation indicates the field is required, thus cannot have an object in our GraphQL API without a value for the ID field. The bracket indicates a one-to-many relationship. One user can create 0 or more reviews, and a review can be written by only one user. To represent one-to-one relationships, we simply leave off the brackets, indicating this is not an array field. The following built-in types are supported by the GraphQL schema language: str, int, float, boolean, id. By default, every type is nullable, meaning null is a valid value for the field. Use an exclamation point to indicate a type is non-nullable. For example, int exclamation point is a non-nullable integer. To indicate a list type, use square brackets. For example, open square bracket. Int close square bracket is a list of integers. Brackets and exclamations can be combined. For example, open square bracket. String exclamation point. Close square bracket is a list of non-nullable strings. Every item in the list must have a string value, but the list itself can be null, while open square bracket. Throw. Close square bracket exclamation point is a non-nullable list of nullable strings. Now that we have our type definitions, we need to define the entry points for our API. The entry points for read operations are defined in a special type called the query type. Entry points for write operations are defined in a special type called the mutation type. For now, we will focus only on queries. Mutations will be covered later, where we will update data in a database. The entry points for our API should map to the client requirements of our application. In other words, ask yourself, what operations does the client need to complete? These needs should guide what query and/or mutation fields we define. This is all for now. Let's continue in the next episode with implementing resolver functions for data fetching. Thank you for watching. See you in the next episode.